Welcome back, students. Today in this video, let us try to solve some of the numerical problems from chapter 9. So page number 134, question number 3. From a rifle of mass 4 kg, a bullet of mass 50 gram is fired with an initial velocity of 35 meter per second. So calculate the initial recoil velocity of the rifle. So let us start solving the problem. So the first is mass of the rifle M1 equal to 4 kg and mass of the bullet M2 is equal to 50 gram. Since it is given in gram, we have to convert it into kg. So for converting, divide by 1000. Why? Because 1000 gram makes 1 kilogram. So if you divide, the answer is 0.05 kg. Now when the gun is fired, the gun or the rifle moves backward. That is called recoil velocity. So let the recoil velocity of the rifle here be V1, and bullet is fired with an initial velocity V2 equal to 35 meter per second. Initially the rifle is at rest, so its initial velocity is V equal to 0. Now here we have to find the momentum before the firing and after the firing. So the first momentum before the firing. Total initial momentum of the rifle and bullet system is equal to M1 plus M2 into V. As we know that the formula of momentum is equal to mass into velocity. So M1 is the mass of rifle and M2 is the mass of bullet. So it is multiplied by velocity. And here, since rifle was at rest and velocity is 0, if you multiply, you will get 0. And now total momentum of the rifle and bullet after firing. So it is equal to M1 V1 plus M2 V2. Here we are taking the momentum of both the rifle and bullet. So M1 V1 is the momentum of rifle and M2 V2 is the momentum of bullet. So we know that the mass of the rifle M1 is equal to 4 and the recoil velocity of the rifle we do not know, so we will write V1 only, plus M2 is 0.05 into V2 is equal to 35. So if you multiply in the next step, you get 4V1 plus 1.75. So according to the law of conservation of momentum, total momentum after firing is equal to total momentum before firing. So total momentum after firing is 4V1 plus 1.75 and total momentum before firing is 0. So in the next step, plus 1.75 will go to the right hand side and become minus 1.75, and 4, which is in the multiplication form, if it goes to the right hand side, it changes to division. So minus 1.75 divided by 4. So if you divide this one, V1 is equal to minus 0.4375 meter per second. So the negative sign here indicates that the rifle recoils backward, which is the opposite direction, with a velocity of 0.4375 meter per second. This question is also similar to the example 9.6. Now question number 5 from the exercise. A truck starts from the rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration and find a force acting on it if its mass is 7 tons. And here's a hint given that is 1 ton is equal to 1000 kilogram. So let us start solving. So here the initial velocity of the truck is 0 since the truck is at rest. So U is equal to 0 meter per second. And the time taken is 20 seconds. Distance covered by the truck S is equal to 400 meter. So here we have to find the acceleration, and we already have S, Q and T. So we can use the second equation of motion, which is S equal to UT plus half into AT square. So we can put the values. S is 400 equal to U is 0 into T is 20 plus half into A, acceleration we do not know, we have to find acceleration, into T square, that is 20 square. So in the next step, 400 is equal to, if you multiply 0 and 20, it's 0. So half into 400 A. So you can cancel 2 and 400. by 200 times, and you get 400 is equal to 200a. So 200 goes down, so it becomes a is equal to 400 by 200. So if you divide, you get 2 meter per second square. Now we have to find out the force acting on it if the mass is 7 tons. So we know that the formula of force is mass into acceleration. So mass is 7,000. Why? Because 1 ton is equal to 1,000. So if you multiply 7 by 1,000, then you get 7,000. So mass is 7,000 here. So multiply 7,000 and 2, and you get 14,000 Newton. N is Newton, which is the unit of force. So the amount of force is 14,000 Newton. That's all for today. I hope you all understood. Thank you.